We'll now discuss another important concept related to force and momentum, that is the impulse of a force. What is the impulse generated by a force? From experience, you know that if a force stays at the point of action for a longer period of time, you can reduce the pinch of that force. If you want to catch a baseball, I know most of you, if a baseball is moving fast, if you don't want to get hurt, as soon as the ball touches the hand, you move the hand back. Now that will increase the time of contact. Now what does impulse of a force means? Impulse represented by uppercase I of a force is the product of the force and the duration of action of the force. So if a force F Newton acting for a period of time delta t, then impulse I equal to force multiplied by delta t. So the quantity defined as the product of force and the duration of action of the force is what we call impulse of a force. But you know that force is a measure of the rate of change of momentum. Do you remember that? Yes? Force is a measure of the rate of change of momentum. So let's replace the force F by change in momentum divided by that time. So F equal to delta P divided by delta T. Let's replace that. Therefore, the impulse equal to force multiplied by delta T. Force is delta P divided by delta T multiplied by delta T, and delta T's will cancel, giving us a measure of the impulse. Therefore, what is impulse of a force? Impulse of a force is simply the change in momentum that the force has created. The impulse is a measure of the change in momentum that it produces on an object. What is the unit of impulse? The unit of impulse is Newton second. Is that right? Which is the same as kilogram meter per second, because the unit of momentum is kilogram meter per second. The unit of the change in momentum also is kilogram meter per second. Can you show that Newton second is the same as kilogram meter per second? Try that and let me know if you got it right or if you need help. Now, when you drive a nail down, longer the hammer stays in contact with the nail, the smoother will be the drive. I'm sure those of you have tried to drive a nail down. If the hammer gets reflected or deflected quickly, the nail will not go down. In order to drive down the nail, the hammer has to stay in contact with the nail for a certain duration of time, and that will be a smooth driving in of the nail. Well, let's do a small problem. When a 2 kilogram, a 0.2 kilogram baseball is hit, its velocity changes from 25 meter per second to negative 25 meter per second. Well, it goes forward, it is reflected in the back in the exactly opposite direction with the same speed. What is the impulse delivered by the bat to the ball? If the ball is in contact with the bat for 1.1 milliseconds, what is the average force on the ball? Well, in order to calculate the impulse, it is a simple calculation of the change in momentum. Impulse is a measure of the change in momentum. So let's calculate the initial momentum and then the final momentum and that will help us to calculate the change in momentum. So here the ball is hit on the bat. Therefore, the initial velocity is 25 meters per second and the final velocity is negative 25 meters per second. The mass of the ball is 0.2 kilogram. Its initial velocity is 25 meters per second. Final velocity is negative 25 meters per second. Therefore, what is the initial momentum? Initial momentum is m times vi, that is 0.2 times the initial velocity, that is 5 kilogram meter per second. What is the final momentum? The final momentum is mvf, and vf is negative 25 meters per second. Therefore, the final momentum is negative 5 kilogram meter per second. What is the change in momentum? Delta P is the final momentum minus the initial momentum, that is negative 5 kilogram meter per second minus 5 kilogram meter per second, that is negative 10 kilogram meter per second. Therefore, what is the impulse of that force? The impulse of the force is a measure of the change in momentum. Therefore, impulse is negative 10 Newton second, which is the same as negative 10 kilogram meter per second. Okay, in B, if the ball is in contact with the bat for 1.1 millisecond, 1.1 millisecond is 1.1 times 10 to the negative 3 second. Well, force is a measure of the rate of change of momentum. This change in momentum occurred during this time interval. Therefore, the average force is the change in momentum is negative 10 kilogram meter per second divided by the time is 1.1 times 10 to the negative 3 second. And that is negative 9.1 times 10 to the 3 Newton. Why is that force negative? The force, you see, the ball hits the bat and the force is on the ball. The force we have calculated is the force that creates the change in momentum, and that force is the force exerted by the bat on the ball, and that is why it is negative. It is opposite to the direction of the initial velocity. Okay, we will now talk about elastic and inelastic collisions. Alright, I want you to follow